So I need what number down here in the bottom? I need a 5. So I'm going to choose to multiply by 5 over 5 because I'm multiplying by 1. The 5 is in the top. I need a 5 down there. I'm going to choose to multiply by 5 over 5. All right. I need this 5 to stay right here in the denominator. But the 5 in the top is extra. So I'm going to use the scalar multiple rule that says I'm allowed to pull that out in front of my limit. So then I've got 5 times the limit as x approaches 0 of tangent 5x over, multiply those, and in order I've got, I'm good there. All right. And again, the property, you don't have to write what I'm writing in red, but the property that I would be using is the limit as x approaches 0 of tangent kx over kx, and that has a value of 1, which means then I can evaluate this part of the limit, and that's 1. So then 5 times 1 is 5. So we good with that? Okay. Now let's see what else we could do. Ooh, yeah. Let's do another one because those two were identical, very, very similar. All right, so let's do one like this. Let's do the limit as x approaches 0 of sine x over 4x. Okay, now let's do some review of trig. All right, we probably didn't do enough trig because of the pandemic year last year. If I take the tangent or sine or cosine or whatever, we were doing things like tangent x or tangent 2x. All right, I never wrote it with a set of parentheses around it because we usually leave them out. In the textbook, you will sometimes see parentheses around that. Whatever is here is a quantity that you can't mess with. All right. You're taking the tangent of that quantity. So I cannot pull that 2 out. I can't put a 2 in. All right. So right here, I have the sine of x, which is really the sine of a quantity, and that quantity is x. I cannot just go, oh, I'm going to slap a 4 in there and make it match. All right, because I'm taking the sine of this entire quantity. So that's not legal. All right, can you tell me what that 4 really is in this problem? Think algebra. Yeah, Chris, 1/4. It's a coefficient. Isn't there an imaginary 1 that's sitting right there also? And then numbers that sit in front are coefficients. So on this one, I can take the coefficients because that 4 is in the bottom and I can move it out in front. So this one I'm going to rewrite as a 1/4. That's the scalar multiply rule, the limit as x approaches 0 of sine x over x. All right, now is that one of our properties? Sine x over x, is that on one of our properties? It is one of our properties. It's the very first one, top left-hand corner. The limit as x approaches 0, sine x over x is 1 because it's a known property. So I am allowed to legally use that. So then this is a 1/4 times 1, 1/4. So in other words, could you have looked at that and then knew what the answer was right away? Yes. Okay, so multiple choice question, you're good. Justification on an open-ended question, this is your algebra that justifies it. All right, so then just real quick, could I do the limit as x approaches maybe say 2 sine x over 3x? What's that answer? Two-thirds. Okay, so you can do them really quick in your head. But if I justified it, what would I do? I would take my coefficients, I would pull it out in front, 2/3 times the limit as x approaches 0, sine x over x. This is a known property. I know that's 1. So it's 2/3 times 1, and there's my algebra steps to justify the 2/3. Okay, so then there's that kind. Okay, now let's step it up a little bit. Let's get them a little bit harder. Let's do something that looks like the limit as x approaches 0 of tangent squared 3x all over an x. And here again, we played around, I think, with this a little bit last year with our trig, but maybe we didn't do it enough. All right, so let's just talk about what that tangent squared 3x really means. Okay, when your textbook writes it like that, tangent squared, and then they can put a set of parentheses in there or not, it doesn't make any difference. Tangent squared of 3x, what is that? That really means that I have the tangent of a 3x and it is being squared. I've got two of them. Okay, so whatever it is being squared. But common notation puts the two here. We are going to, in our work, especially when we get to derivatives, we're going to take this and rewrite it like this so that we can clearly see this is the base and this is the exponent. I'm taking this, I'm multiplying it twice. All right. So knowing that, all right, let's make that our first algebra step. All right, let's make that our first algebra step. So the limit as x approaches 0, tangent 3x to the second power all over x. So all I did was an algebra step there, no limit, nothing. Okay. Now, didn't we have one of our properties that said that we could multiply two different limits and then that's still going to give us the overall limit? Remember when we did those properties where we added and we subtracted and we multiplied and we divided? All right. Don't I have two things being multiplied here, right? Okay, so I'm going to go ahead and put the square things in because that's kind of important. I'm taking the limit of this entire quantity. Now, let's go the limit as x approaches 0. All right, now there's two of these on top. I'm going to leave one on top, tangent 3x over x. Now, I have another one, but it's not going to be over x. It's just going to be over 1. Multiply it by itself, tangent 3x. So all I'm doing is kind of taking this, rewriting it into two individual limits, okay? Because then I could, if I wanted to put an extra step in there, I could say the limit of this times the limit of this. I could write using that property that we did the other day, or I can just know I'm going to work on this, take the limit here. I'm going to work here and take the limit here. All right, now, I want to separate it. Let's separate it on this first one because this is the first time we've done it. So let's do the property from the other day and separate it. Let's do the limit as x approaches 0 of tangent of 3x over x, and then times the limit as x approaches 0 of the tangent of 3x. Okay, that is a property. That's a legal move. Let's separate it. For right now, I don't want you skipping that step. Later, I'll maybe let you skip this step. All right, now, does this look really, really close to one of our actual properties? It does, right? It's got a kx and missing my kx on the bottom. All right, I know what this limit is. This limit is 3, but let's show our steps. I need to choose what as a form of 1 to multiply this one by? 3 over 3. So I'm going to choose to multiply by 3 over 3. All right, this 3 is extra. So he's going to come out in front. This one needs to stay in my denominator. Okay, so I've got the 3 out in front. I've got the limit as x approaches 0, tangent of 3x over 3x. So I'm good there. That's good because this is a known property. I know the answer now to that. All right, now over here, this is not a property. Okay, so what's always been the first thing we've been doing, we've actually always, and I've been kind of skipping it from the very beginning, but we should do a direct substitution. If it's not a property, I'm going to try a direct substitution and see what happens. All right, so I'm going to actually, with this limit, I'm going to do a direct substitution and see if I can get an answer, which means I would plug in when I take my direct substitution, when I take my limit, the limit notation drops. Okay, so right here, then I just need what? A tangent of 3 times 0, which would be tangent of 0. Do we know tangent of 0? Ooh, from our unit circle. You're all going, oh crap, I got to remember that unit circle. Okay, tangent of 0 is what I'm trying to do. Okay, 0 is right here, right? So our unit circle, and so 0 is right here, right? The ordered pair is 1, 0. Do we remember this? My first one is cosine or sine. The first cosine. Second one is sine. How do we find tangent? Tangent is, do we remember? Sine over cosine. So that would be 0 over 1, which would be 0. So my tangent is going to be tangent of 0 is 0. Like, oh my God, I got to remember all that stuff from pre-calc. Yes. Okay. So this one is a property. I know the answer to this one. I did a direct substitution, which then just allowed me to do good old fashioned math right there. So basically I have what? I have a 3 from here. This property is 1 and the tangent of 0 is 0. So my overall limit, 0.